Okay, so we are on February the 10th. We just had our second quiz. Today we do more modeling. What does the word modeling really mean? Story opportunities. No problems, only opportunities. Somebody, one of your classmates came to my office yesterday. Ian, I got an opportunity. Okay, so we do another day of the word problems, and then the next 3 days are all about graphing stuff, and then that's the end of the material for the test, okay? The test is on 10 different days worth of material. We have finished 6, so we're more than halfway to the test. The test again is on, when is that? 27th of February. Is that right? Nope. 24th of February. Okay, it's coming up. Not too early to start studying. All right. Do you guys remember, so last class we just did a few problems. How many problems did we do last class? We did 7 problems because they were long, right? These are involved questions that we had to tackle. Today we tackle 5 problems. Only 5. What does that mean about these problems? They're even harder. Okay, but 5 is all we have to get through. So let's start. We'll go to number 1, Megan. Okay, so I'm hoping that that makes sense in terms of the lead-in, but like every one of the problems that you guys tackled last time ended up being a linear equation. Here it was r to the first, no squares, right? Everything was just first powers. That was the canoe question. You did some investment question. What power do you see on the B? First power. Every question last time was linear. Here was a mixture with the chocolate milk. What power do you see on the M? First power. Today, things are going to get ramped up a little bit in terms of difficulty because the equations that we get after we set up the table are going to be quadratic equations. So same idea in terms of setup, but then the final step where you solve the equation will be a little tougher. We'll go to Hazen for number 2. Okay, thank you. Not so easy to read all these symbols. So this V0 business, you could just read it as V0, or you could read V sub 0 if you want to. And it's a little subscript that indicates time is 0, meaning we are starting the experiment. So anytime you see a little 0 on a letter, it probably means it's an initial something. So if you're up at the top of this building and you have a ball up there, the ball has an initial height before we throw it off. And then at the moment we throw it, maybe we throw it upwards, it's got an initial velocity. And so that initial part is supposed to be indicated by the zeros, okay? They're just part of the name. They don't really have anything to do with how high the ball is or how fast it's going initially. They just say initial. Okay, so I really get annoyed when I put grammatical errors in my notes. Does anybody find one in that sentence? I can't believe I did this. Yeah, all right, so ball and body, maybe. Yeah, what do you see, Sam? Yeah, it's not it is. It's ITS, no apostrophe. Allow me to hang my head in shame for just a moment. Okay, I will fix that. All right, so here's a formula. So what do we do with that formula? Well, let's keep reading and see what we can do here. All right, we'll go back to Sam. From? Okay, so let's see if we can plug some stuff into our new formula here. All right, so I got there's an equals there. I don't know what h is at the moment, so leave that blank. Negative 16. T is how long the ball is in the air. It's time. It's not 96, but we'll come back to it. The 96 is going to go somewhere. Plus. Okay, v sub 0 is the initial velocity. How much is it? 40. So that's a 40 times t. T is just how long the ball is in the air. Plus h sub 0 is the initial height, which is the 96. Okay, so Sam, that's where the 96 goes. There's one other number in the problem. That's the 24. I will tell you what this formula is giving us. This formula tells you how high the ball is off the ground for any time t. For example, if you plug in t equals 0, what do we get? 96. Meaning when you start the clock at time equal to 0, the ball is 96 feet off the ground. Is that true? Yes, it is. If we plug in t equals 1, just plug in t equals 1. So let's see, that's minus 16, that's 80, it's 120. You plug t equals 1 second, you get 120. 1 second after I throw the ball, where is it? 120 feet off the ground, higher than it started. If you plug in t equals 2, this is tougher for me, 32, another 80, I think it's 112. 2 seconds after I let go of the ball, where is it? 112 feet off the ground. But 1 second, it was 100, what was it, 120? 120 feet off the ground. What's happening? If it used to be 120 and now it's 112, it's now back on its way down, right? It's eventually going to start coming down. If you plug in t equals 3 seconds, it's going to be probably even lower than it started, right? At some point, it's going to come back and pass us. And so that's what this formula is giving you. Any questions on that formula? Yeah, Sam. Mm-hmm. Oh yeah, so how does it get to 40 from nothing? Yeah, yeah. No, that's a good point. Good point. We can. No, it's a good detail to think about. Like I guess further assumed in this problem is that like the ball is shot from a cannon, but we don't start the clock until it reaches the 40 feet per second, right? Don't start it when it's initially accelerating. Just start the clock when it's at 40. But you're right, it's a good detail. All right, I want the height to be 24. Is that the value of t? No, t is time. It's the other side. I want the whole thing to equal 24 to tell me when this thing is back down to 24 feet above the ground. That's where the 24 goes. When is the height equal to 24? By the way, one thing that was always mysterious to me until I understood it a little better is that negative 16 is just a random number in the middle of this formula. Like everything else in the formula has to do with the problem. 40 feet per second, 96 feet off the ground, t is time. Okay, so all that has to do with the problem, but somehow it's always a negative 16. It has nothing to do with how fast you throw it or how high it is in the beginning. Anybody know? Yeah, negative 16 has to do with gravity. The acceleration due to gravity, does anybody know it in feet per second squared? Turns out it's negative 32. That's what gravity is here on Earth. Negative 32 feet per second. And 16 is half that. And that's why it's always 16. I don't know why it's half. Can't explain why it's half, but I can tell you it has to do with gravity. If we were doing this experiment on the moon, it would not be 16 anymore. It would change. Okay, what kind of equation is this? That's a quadratic. That's what makes it a today problem compared to a Wednesday problem. So how do we solve this quadratic equation? Well, what do you like to get on one side of quadratic equations? You really like 0. This is me personally. I also really like positive in front of my t squared. So instead of bringing the 24 to the right, I'm actually going to smush everything over to the left. So if you add the 16t squared, it's positive. What about this 40t? It's minus. And then we subtract the 96, and what do we have left? Is that right? Questions on that? I moved the 96 over to the left. Okay, so add and subtract everybody from the right-hand side, bring it to the left, so we have a 0. Okay, this is a quadratic equation. If we're lucky, how do you solve a quadratic equation? Factoring. You want to try? I don't particularly want to try to factor this thing. The 16 is very challenging for me. 72 has an awful lot of factors, and the numbers are going to be quite big. I'm not saying it doesn't factor. I'm just saying at some point you give me crazy numbers, I'm just going to bail out and use the quadratic formula, even if it turned out it factored in the first place. One thing I would do before I use the quadratic formula is I would divide everything there by the greatest common factor. What number goes into everything?
That should be minus 72.
I brought everybody to the left. So all of my signs could be different from all of your signs, and that's okay. I subtracted the 96. Yeah, I changed everything. What number goes into all those coefficients? 8 goes in. So let's divide everything by 8, both sides. When I divide this guy by 8, I get 2t squared. Divide this one by 8, minus 5t. Divide this one by 8, minus 9. Divide this one by 8. Don't forget, you're dividing everything by 8, including the 0. That's okay, it's still 0. Okay, with these numbers, I might be tempted to spend a minute trying to factor. It's up to you whether or not you want to try. Certainly the quadratic formula will work no matter what. Okay, so let's give the quadratic formula a shot. How about we just bail out on the quadratic? Does anybody need to see a quadratic formula worked out? We all know how to do this, right? Okay, let me show you guys a website. If you guys type in here Wolfram, or if you start typing Wolfram, the very first one is Wolfram Alpha. Has anybody ever been to this site? A couple of people. Wolfram Alpha is attempting to be the Google of scientific knowledge. It wants to be the place that you go if you want to learn anything about knowledge. Google is a place you go to learn stuff about whatever you're interested in, but if it's like hardcore science, math, factual knowledge, they want you to go here. And it's not going to send you to these random sites that are listed by popularity. It's going to stay right here. Okay, so here's what I want to type in. What was the equation? 2t to the second. That's the button for second, yeah? Minus 5t minus 9 equals 0. Okay, and one thing I'll type in here, solve. Okay, there you go. There's the answer from, it looks like the quadratic formula, right? 5 plus root 97, 5 minus root 97 divided by 4. So you've got the radical version, you've got the decimal versions. If you like graphs, there's the graph. There are the solutions on a number line.
If you switch over the equal sign, it's upside down.
Oh yeah, it's upside down because we switched it over. Yeah. Okay, I got two answers here. Does it take negative 1.2 seconds or 3.7 seconds to go up and then come back down to 24? 3.7, right? The negative is in the past before I even started. We reject that answer. But 3.7 seconds is the answer to this question. Any questions on that? Okay, so given that Wolfram Alpha exists, why do we even bother? Why are we doing anything? Well, I guarantee you, if you typed into Wolfram Alpha this question, given a ball 40 feet per second, 96 feet off the ground, I don't think it's going to know how to tackle that, right? This is where we come in and we do some interpreting and eventually we come up with some equation. But the part that we contribute as thinking humans is the getting to the equation. Analyze the problem, get to an equation. Solving equations is a very rote process. Computers are very good at it. But it's the getting there that's our contribution. Okay. Okay, so what was our answer here? T is roughly 3.7. I'll say thanks, Wolfram. Okay, number 3. Who was our last reader? Is it Eliza? Can you read number 3? Mm-hmm. Okay, thank you. So we're going to make a table. Notice this is the first problem we've had without the table given, but we've seen this table before, right? Rate, time, distance. Okay, and this table has 2 rows because we've got the first part of the trip, the Tortula to Cactus, and then the second part, Cactus to Dry Junction. 2 trips, 2 rows. What would you like the third row to be? Mm-hmm. So if you'd like to add a total in there, you can. At this point, I don't know whether or not we'll use it, but there's no harm in putting it or just waiting. Either way. I think we're going to definitely use something to equal at the end. I don't exactly see it, but if you just want to always include a total or a mixture row, perfectly fine. Now let's start filling in. First thing I see is this 250. Where does that go? Okay, so that's this top right, 250. Okay, any other easy numbers to plug in here? Just like a straight. Okay, so the bottom right is the 360. And so the rate is 10. Yeah, so we don't know what it is. We do know that we went 10 miles an hour faster. So yeah, we're gonna introduce an x someplace. So let's see. Here's what I want to make sure we do. I want to make sure that when we find our answer, like x equals, that we've actually answered the question. So I'm gonna let x be the rate from Tortula to Cactus. Although, to be honest, I'd prefer r for rate, but x is totally good. And then we get to this part. Yeah, Joe? Okay, so total time. So maybe we did need that bottom row, 11 hours total. And then we get to this business about increased her speed. So she was going R, now she's going increased by 10, so R plus 10. Okay, so here's where things get a little bit funny. Which column was always the last one we filled in the other day? Wasn't it the distance column? The far right one was always blank. It's not blank now. Now we're trying to fill in a time column, which is not a that times that equals this. We have to do a little work here. We know that rate times time is distance. Yeah, we need to know what time is equal to. So divide by r, and we get the time is the distance divided by the rate. Well, I think we can put something with r in it. I think that's okay. What this says is that to fill in the time column, you take the distance column and you divide it by the rate column. So we take the right hand divided by the left hand. So over here, the time is 250 divided by r. Can you guys fill in the last one? So do we get 360 divided by r plus 10? Whatever the distance is divided by whatever the rate is. And unfortunately, this is going to give us a tougher thing to solve because now all of a sudden we have division. We have denominators. but there's no way around it. Do you guys see where the equation is going to come from? What number haven't we used yet? And the lonely 11 at the bottom is the only thing we haven't used. So how do we get an equation out of this table? Yeah, we're adding the middle column up and we're getting 11. This top middle number, that's how long she took for the first trip. The bottom middle is how long she took for the second trip. But I know it was 11 hours total. So we're adding them up and making it equal to 11. Okay, this equation is a lot harder than the equations we had to solve last class. But we have seen equations like this, where there are x's in the bottom. We have a technique to solve this kind of equation. We need to multiply both sides by the least common denominator. Can you guys look at it and see what that is? You're going to need an r to cancel this denominator. I'd really like to put an r up there to cancel that, so we'll need an r. What will I need to cancel the other denominator? An r plus 10. And even though there's an r in both, they're really different. Addition is not our friend. Michael? I think you could use a fufu, yeah? Yes, absolutely. That would give you, you could build the same denominator for both. Is that where you're headed? Yeah. Yeah, that works, absolutely. For me, I always multiply both sides by the LCD to get rid of the fractions. Fufus work perfectly well. Okay, so I'm going to stick this next to every one of my fractions. So I've got an r and an r plus 10. I squeeze it in here, r plus 10. And then on the right-hand side, don't forget, everybody gets multiplied by r plus 10. Okay, if you're doing things right, lots of stuff should cancel. In this first fraction, what cancels? R's cancel. In the second fraction, what cancels? R plus 10s. Don't distribute over there until you first cancel. So what we've got left is this 250 R plus 10, 360 R, and then I'll copy the right-hand side. What can we do now? I think we need to multiply everything out. Let's distribute it all. What kind of equation is this now? Now it's quadratic. Now we see why it's here today. After all this work, we finally get to a quadratic. Okay, so let's see if we could at least get 0 on one side. First, I'll combine over here. How many R's? 610. And now we'll bring everybody to the right to make a 0 over there. I had 11R squared. Nothing's going to change that. I used to have 110R. We need to subtract minus 500R. Everybody see the R's come together? And then that 2500 comes over to the right. I'll move it up a little bit. Are we ready to hit Wolfram? Okay, so factor if you're feeling really lucky and dangerous. Otherwise, quadratic formula. Otherwise, Wolfram Alpha. Okay, so we come up here and we just type in. The thing I like about this is you don't have to know any syntax. You just type in English, solve, and then you write the equation. So what was it? 11r squared minus 500 minus 2500 equals 0. Okay, there we go. Two answers, 50 and negative 50 elevenths. These are supposed to be r's, rates of speed. Which one gets rejected? The negative 50 elevenths. So apparently she was traveling 50 miles an hour for the first leg. And how fast for the second one? 60, 10 more. The fact that these were nice numbers, 50 and negative 50 over 11, means what could we have done to solve the equation? It could have factored. That's what it means. If we had nice numbers as the answer, this must have factored. And in fact, we'll get to this, later in the term, but one of the answers was 50, right? Well, what's the only way you're going to get 50 is if you have an r minus 50. That's the only reason 50 was the answer, because one of these was r minus 50. We're coming to that later in the semester, but I'm just kind of like building backwards from the answer. What was the other answer? It was 50 over 11, right? 50 over 11, let's see. So there's my 50, there's my 11, and it was negative, and somehow that, if I asked you to solve this piece equal to 0, you get negative 50 over 11. That's the factoring. If you FOIL that, you'll get the right answer. But coming up with this factoring, I don't know. It was a lot easier knowing what the answer was beforehand. So either that or more likely quadratic formula. And we get r is equal to 50 or negative 50 elevenths. And this one here got rejected. Can I do one more Wolfram Alpha thing, and then you guys are going to do the, you have 3 problems to try? So Wolfram was really good at solving quadratic equations, right? Like really good at it. Well, we did a lot of work to get it to be a quadratic equation, but we had an equation way before the last one. I'm going to copy this guy before I put all that stuff in. Wasn't this the equation we had? 250 over r plus 360 over r plus 10 equals 11. Wasn't that the first equation before we did all the work? Okay, let's just see. I don't know what's going to happen. I know what's going to happen. Okay, solve. So what is it? 250 divide r plus 360 divide, make sure you put parentheses. R plus 10 is one thing, but we need to let the calculator or computer know it's one thing, equals 11. Remember, we did work to make it not a fractional equation and then get it into standard form. And you can see the answers here. Quite familiar. Negative 50 elevenths and 50. Again, so you're asking yourself, why do we do anything in math if we have this? And it's because our job is to translate all those words into some equation. And then solving equations, computers are quite good at that procedural stuff, but they can't do the analysis that we did. All right, not yet anyway. Okay, can you guys go to the next page? There are 3 questions. One of them is a coin. Next one has to do with area and farming. And the last one has to do with driving. So give it a shot. Flags are on the table, and I'll walk around and talk to each other.